Okay, I think it's a good time to start. So, hello again, and welcome to week 7 of these weekly live discussion sessions for the course Foundations of R Software. So, I'll start sharing my screen, and please let me know if I'm audible, and also if you can see the R Studio screen. So, you can hear my voice, and the R Studio is visible to everyone, right? Okay. So, let's begin our discussion from where we had ended it last week. So the last topic that was discussed in week 6 lectures, and which is the starting point for week 7 lectures, is about sequences in R. Now, from the very beginning of this course, we have been defining various different types of data, scalar data, such as just a number, let's say x equals 1. We have also defined vector data, so using collections of this form. We have even gone as far as to define matrices and so on. So, one of the ways that we had noted that we could get a constant, so we can get a sequence of integers with a constant unit separation was by using this colon notation. So we just give the starting number, the colon, and the ending number, and automatically R was returning a sequence of integers which were separated by 1 unit. Now, of course, there are variations on this. So if instead of 1 to 10, if you just say 10 to 1, what it will do, it will basically give the above output in a reverse order, and here the step from one object to the other is -1 instead of +1. Now we can explore this further. We can try to see. So we have had detailed discussions on why this returns a sequence of integers, not a sequence of fractional numbers, because again, if you are working with fractional numbers, the choice becomes arbitrary as to what the step size should be. So after 1, should it be 1.5, should it be 1.2 or 1.1? That's not clear if we are not explicitly mentioning that. But let's say we just give either the starting or the ending point as an integer. Let's say if I put 1.23 to 10. What happens is, R again follows the same philosophy. It starts with this number, uses a step size of 1, exactly 1. So after 1.23 it gives 2.23 and so on till we encounter a number which is smaller than this. I mean, not larger than this. So because the next entry after 9.23 would have been 10.23. That would have crossed this limit. So that's why this sequence stops at 9.23. So again, the underlying idea is the same whenever we are using the colon notation. And again, we can do this in the opposite order. And what you will notice is that the result is slightly different, because now it's first looking at 10, and the second entry here after the colon is smaller than the first entry, so it will start decreasing in units of 1, or it will keep adding -1 to each element. So it will start with 10, 9, 8, 7, 6, 5. It will come all the way up to 2. The next one would have been 1, which would have been smaller than 1.23. But that's where the limit has been drawn. So this only gives up to from 10 to 2. Now if both the boundaries are, let's say, integers, then again what happens is again the similar operation. It starts with this number, increases in units of 1, and just tries to see when this limit is breached. So after 11.23, next one would have been 12.23. So that is why the sequence ends here, because this is smaller than 11.4. And even if you do it in opposite order, it works fine. So we must be aware of how these commands will behave. And of course, you can do something different. You can put a minus sign, so you'll get negative numbers. But that's all the freedom we have with the colon. We can give negative numbers, we can give positive numbers, we can give them in opposite order, we can introduce decimals, but the step size is not under our control. So that is why we use a more complicated function which is known as this sequence function or the sequence command. Now, if you just want to obtain this result, a sequence from 1 to 10, you can just give it the sequence 1 to 10. That will give the same output. Or if you don't give anything, you just say sequence and 10. It assumes that the starting point is 1 and you want up to 10, so it will give, and again the step size has not been mentioned, so it will just increase in units of 1. But we don't want to do that. We want to use the actual power of this sequence command. So let's see how this sequence command works, or let's revise how the sequence command works. You first give a starting value, then you give, let's say, an ending value, so where to start the sequence, where to end the sequence, and then you can give the step size. So let's say I want to increase in steps of 0.5. So starting from 1, going all the way up to 8.5, increasing in steps of 0.5. Now let's say you are not familiar, I mean you know the starting and the ending point, but you don't know how many elements you want. Or sorry, you know how many elements you want, but you don't know what the step size should be. I mean you can always calculate, but that's where the other arguments of the sequence command are useful. So let's go to help. Let's see what else sequence offers us. So there is, the first one is called from. So it's always a good idea that if you have named arguments, to use the name so that there is no confusion. Let's say from 1 to, let's say, 25, by, which is what is the step size. So by what size should I make the jump? So here the size was 0.5, so 1, then 1.5, then 2. So of course, if you know the length, if you know where you are starting from and where you are going to, you can calculate by, which is 2 minus from by length. Now, let's say in this case, we don't want to give the length. Sorry, we don't want to give the step size, but we want to give the length. So we'll just say length equals 10. So I want 10 equally spaced numbers from 1 to 25. So now you see, the step size is automatically calculated for us, right? So you can count, there are 10 numbers in the sequence, starting from 1 up to 25. And the step size is 2.666, right? That keeps going. So that's why the fourth entry is 9, then somewhere you have 17, then you have 25. That's how it's working. Now, of course, you can make it more involved. So what you can do is, we already have some variable defined, say x equals 5. So I can give the arguments of this sequence in terms of this variable. So you don't have to explicitly mention these numbers from, to, length, by, and so on. So you can just say start from x, go all the way up to 5 times x, and give me 10 numbers. So that's what it's doing. Now, when you're looking into this sequence command, there is another argument here called along. So what along does is basically you give the sequence a vector. So we already have a vector y defined. So if I say give me a sequence along y, what it is doing is it is giving me the indices of each of the numbers in y. So the first, or basically the positions of the various entries. So It starts from 1, then 2, then 3, then 4. So if you just say sequence along y, it will just give you a sequence of numbers, a sequence of integers starting from 1, going all the way up to the length of the vector. Okay. Now moving on. So far what we have discussed is about numbers, but the sequence command is more powerful than that, and we can also use it to, make sequences of other things like date and time. So you'll ask me, why do we need sequences of dates and times? So maybe sometimes you're working on an experiment where it's quite time sensitive and you want to record what is happening at each moment. So maybe you are setting some step size for the time itself, that okay, you want to observe what is happening every 5 minutes or every 1 hour. Or maybe if it's something even slower, you want to see what's happening once every day. So that's why it's important to have sequences of dates and time. So if you want to just know the date, there is this sys, just short for system, dot date, this command, which just gives you the date according to your computer. So it's 10th of September today. So it's giving me the command as 2022, the year, 09, which is the month, and 10, which is the day. And similarly, you have sys system dot time. So this is giving me the exact time. So this is the date. This is 14 minutes past 5, and the seconds, that's the seconds which was the moment when I executed this command. And IST is just Indian Standard Time. So if you just put time zone, it will say Asia, Kolkata. That's how the time zone is stored in the computer. So of course the sys library contains many other commands, but we don't need most of them for the time being. So now, so how do we define sequences of dates? Now of course, dates can also be stored as variables. So we call this D1, and I can check if this is a date or not. Let me see if we have a is.date command or not. Okay, that is not a command. But in general, what we can do is we can use this as.date, and we can use that to just, let's say, if we feed a date, say 1998, 02, 02, something like this, and this becomes a date object. So this is what is needed when you give the from and to arguments inside the sequence function to define a sequence of dates. So let's look at one example explicitly. So let's say we give 1st January, and then we want to go all the way up to today's date. Or we have stored that in D1, right? So let's use D1. Now, when it comes to the by or the step size, there are different ways in which that can be implemented when we are talking about dates and times. But let's first look at the default behavior, and we just give length equals 6. Let's say I want 6 dates from 1st January to now. So if I'm only giving the length, again what it is doing, it's giving me equally spaced date intervals from 1st January to 10th September. So the number of days between each of the consecutive dates is the same, and that you can check. Now, explicitly, what we can do, there are a few options when dealing with dates. You can ask that give me a sequence of dates starting from day 1 to day 2 separated by days. This will give you a long list. 1st January, 2nd January, 3rd January, all the way up to today's date. The other option is you can ask in terms of months. So in this case, it's just 1st January, 1st February. It comes all the way up to 1st of September. Because in this sequence, the next entry would have been 1st of October. But that is beyond the final entry that we have set. And of course, so let's make it slightly different. So just say 2027 and 20th February. And now instead of by months, what we want is by years. So again, taking the first entry and taking the step size that you have mentioned, it tries to go all the way up to the final entry, but it tries to stay either equal to or less than that entry. So 1st January 22, 1st January 23, all the way up to 1st January 27. Now, we have seen how to make sequences of dates based on days, months, years, and so on. So this is a question for you guys, so just to check if you're paying attention or not. When we were discussing sequences of numbers, we had something like this, 1 to 10, but we also had something like 10 to 1. So we were discussing both types of ordering. But the date example that we have shown is only in one direction. That's from the earlier date to the later date. Can we do something like this? I mean, can we write the dates or prepare a sequence which gives the dates in an opposite order? So the later time comes first and the earlier time comes last. So based on this week's lectures, are you guys aware of one such construction? I mean, what do we need to change when we are giving this sequence?
Sir, we would have to change the by. We
Okay.
have to add minus sign.
Okay, so let's say if I put. Okay, so I will not make a suggestion right now. So I'll just do what you tell me to do. So you want me to put it minus 1 year, right?
Sir, you would have to also change the dates.
Right. That is what I was expecting. Because if you just change the step size to negative, now there is no way. I mean, by starting from 1st January 2022, you cannot reach 28th February 2027 by decreasing the year. So the from and to has to be given correctly. So now you see, this is one advantage of named arguments. So I did not have to change this, I just changed the name of the argument. So by default, the first one is from, the second one is to. But if I explicitly say that I'm writing to first and from next, then R understands what I'm trying to tell. So it starts with 28th February 2027, decreases by 1 year, and ultimately reaches 28th February 2022, which is the nearest date, just larger than this, my end point, basically, 1st January. Because next one would have been 2021, but that would have been beyond this limit. So, this is how you try to create sequences of dates and time in R. Now, just like R has an implicit understanding of what I am trying to say when I say 1:10 for numbers, similarly, just to simplify our job, so that if you are working with characters or letters, we don't have to explicitly define sequences. So R already stores these lowercase alphabets and uppercase alphabets in these two variables. So this variable letters, it's a sequence starting from A all the way up to Z. Similarly, letters with everything written in capital is also a sequence from A to Z, but all capital. So now you can treat these sequences just like you would any other. So if you want a piece of this, you do what is known as subscripting, or subscripting as well as slicing. So I just want the first 10 alphabets uppercase. So this is how I will access them. If I want something from the middle, let's say I want from 15 to 10. So this will give me starting from the 15th alphabet all the way up to the 10th alphabet, but in an opposite order. Now let's see if R allows us to rewrite this or not. So now I've defined a user variable called letters, which has the same name as this variable from R. So now, can you explain why it is giving NA, 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 NA? Anybody?
Sir, because letters now you have assigned it as a numeric value.
Right. So it is no longer a sequence. It is. So if I'm asking for the first 10 entries, there are no entries beside the first entry. So there is only 5 here. Everything else is missing. So this is again a warning that there are some words, some keywords, or some variables that have some built-in meaning in R. So it's a good idea not to use those as names of your variables. So letters and letters, I mean, all small and all capital, they already exist in R. So don't define a variable called letters, because that will create confusion and will lead to unexpected behavior. Okay. So the next one is something called repeats. So the meaning is clear from the name itself. You want a repetition of something. Now if you remember from last week's discussion on functions, we had discussed a sample command. What the sample command did was pick up random values and you tell it where to pick those values from, and it will give you as many times you instruct the command. So if from a vector, let's say I have sample from y and I want 2, so it will, first time it picked up 12, the second time it picked up 14. But this is selecting values. This is not repeating anything. This is repeating the action of selecting values, but sometimes you want to repeat the values themselves. So for example, let's say if I write z equals this collection of 1, 2, 2, 3, 3, 3, 4, 4, 4. Let's say this is what I want to do. I want a vector of numbers, or let's say a vector of digits in which each digit has been repeated the number of times as its value. So 1 appears only once, 2 appears 2 times, 3 appears 3 times, 4 appears 4 times, and so on. Now if I increase this value, so here I'm only doing this for 1 to 4. If I want to do it for 1 to 50, you don't want to type all of that. So that's where this repeat command comes in handy. So, okay, this is the target example that we want to see how to build this. But let's first try to understand the repeat command in simple ways. Then we'll try to create an array where this repetition is done. So, what repeat command can do is, you can give an argument which can be a scalar, a vector, a matrix, or any other type of data that R deals with. So, and I mention how many times I want to repeat it. So I start with x and I say I want to repeat it 4 times. So this is the simple operation. You just say what you want to repeat, how many times you want to repeat. Now let's say instead of x, I want to do the same on y, which I know is a vector. So notice how this is doing. So 12, 13, 14, 15, that was the entire content of y. So it's printed y one time, then it's doing the same thing a second time, a third time, and a fourth time. So we are basically, it's print y, print y, print y, print y. How many times? So here I mentioned 4 times, so it will do it 4 times. But there is another possibility. Now I want to say y is a vector and I want to repeat each element of y 3 times. So that is different from repeating the entire y. Because now it looks at the first element, repeats it 3 times. Then it looks at the second element, also repeats it 3 times. Third element, fourth element, and so on. So even if I write repeat y each element 4 times, and when I had written repeat y each 4 times, so you can clearly see the difference, right? Because the entirety of y is printed once, then the entirety of y is repeated. But here, each element of y is being repeated, and then we move on. So these differences are important, and based on this combination of times and each is how we can achieve something like this. So let's say I say that initially my z is just this vector from 1 to 4. That's 1, 2, 3, 4. Now, can anyone suggest that if I want to obtain something like this, what is more useful, the times option or the each option?
Sorry, each.
Each, because we want to focus on each element one by one. So, can someone suggest what should be the argument of, what should be the value given to each? Should it be a number or should it be something else?
Sir, Z.
Okay, okay. It's an interesting answer. And can you explain the answer before we execute?
Sir, like in Z, it is written 1, 2, 3, and 4.
Yes.
So if we want to repeat one time, then it will take 1 for 1. Then in the second element, it is 2. So 2 will be repeated 2 times. Then like 3 and 4 also, same manner.
Correct, correct. But let's say I want to do something different. I want to repeat 1 4 times, 2 3 times, 3 2 times, and 4 1 times. 1 time. Then what should I do? Then what should be the argument of each?
Sir, then we would have to provide a vector.
And what would that vector look like? What is that vector? You're on the right track. So
Uh, Sir, like the number of times we have to repeat each vector, that would be the elements of that vector.
so something like 4 3 2 1,
Yes, sir.
or we can even make this simpler because we know 4 to 1.
Yes, sir.
Okay. And the other option was this 1 to 4. So it seems like this did not work. So this only picked up the first element. Okay, let's try the other way. We just store the variable. Ah, this is surprising why this is not working.
Or sir, we would have to use C1234.
Mhm. It's still not working. So okay, got it. So we don't have to explicitly say each, but then it works. Okay, each basically expects a unique number. So when you want to do a repetition like this, repeat z, where you're repeating each element equal to the number of times or equal to the value of that element. You just give these values without any argument name, basically. So in other words, if you just want to repeat from 1 to 50 and you want to repeat them, let's say in the opposite order, 50 once and just 150. And basically use something like this. So just use two vectors. First vector detailing what you want to repeat, second vector detailing the pattern of your repetition. And as with vectors, it's important that the size of these arguments is compatible. So because here I have given a vector of 4 elements, here I am only giving a vector of 3 elements, so that will not work. Another thing to note is that repetition, number of times you can repeat something, that has to be a positive integer. You cannot say that, repeat 4 minus 1 times. That does not mean anything. So this is all about repeat. And now, of course, as with all data, one important part of handling data is arranging data. And the simplest form of arrangement is ascending or descending sorting. So let's go back to this example, or okay, let me use a different name. So let's say use 1, 10, NA, and 5. And what I want to do is I want to arrange this vector in an ascending order. The way we do that is by using this sort command. We first mention what we want to sort, and decreasing equals to. So if we want to do this in a descending order, we set decreasing equals to true. Otherwise, we set decreasing equals to false. Now, there is one more argument, but let's first see the simple execution and then see what to do with that. So, it took the numbers into consideration, it omitted the NA, and just gave you 1, 5, and 10 in ascending order. Now, handling NAs can be done in a variety of ways. So, by default, NA.last is set to NA, which basically means don't do anything with the NAs. But what you can do is you can set this equal to true, and all the NAs will be basically sent to the end. So let's say if we have more NAs here, and we do the sorting, you see all 3 missing values have been shifted to the end. And if I make this false, all the NAs are shifted to the beginning. Now this kind of filtering is necessary when you are trying to pinpoint what is missing and what's not. So let's say you want to ignore what is missing, you don't want anything to do with those data, then you can just either use the default execution or set NA.last equals to NA. So those will not be returned. But let's say if you want to explicitly pinpoint where the missing values are, you can set NA.last equals to false. So all the missing values, because this is a simple one-dimensional vector, you can have complicated situations where in a single row some entries are NA, other entries are available. So you want to figure out that what information is missing. So in that case, it's a good idea to sort by that particular column which is presenting the NAs and put the NAs in the beginning. Now, sorting can also be done on characters. So let's say C, B, D. And if I just sort V2. So you see, since by default decreasing is already set to false, when I do this operation on characters, I get the, the first alphabet or the smallest alphabet first. So this is the dictionary order. B comes before C, C comes before D, and that is the order which is presented. And if you do it for more complicated strings, so again, this follows the dictionary order, because in the dictionary, car comes before cat, and cat comes before catch. Of course, you can change that and say decreasing equals true. So this is the opposite of the dictionary ordering. Now, there is an important command called order, but there is some difference between order and sort. So to understand that, let's say I've defined something like V3, which is, let's say, 15, 12, 22, 7, 1. So now, if I want to access some element of V3, just call the third element is 22. So this is how the ordering is done. So 15, 12, 22, 7 and 1. Now you can sort it if you want. And it will return in the order of increasing numbers. So 1 is the smallest, so 1 comes at first, then 7, then 12, then 15, then 22. But notice this. So this is 1, this is 3, this is 4, this is 5. So what I've written is the index of each of these. Now once these get sorted, so once this becomes 1, 7, 12, 15 and 22, the original indices are now in different positions. So 1 was 5, 7 was 4, 12 was 2, 15 was 1, and 22 was 3. So if I just say order V3, this is what I'm getting. So what this is telling me is what should be the right order based on the current indices. So in V3, the index of the smallest number is 5. The smallest number is 1, but its index is 5. So if I have to order V3, the fifth element should come first. The fourth one is the second smallest. So the fourth element should come next. Then the second one, then the first one, and lastly the third one. Now of course, if I set decreasing equals true, this changes. So instead of, so the third element was the largest. So the third element was the largest. So when I say decreasing equals to true, that's what it is telling me. The third one is the largest. The first one comes after that, second one after that, then the fourth, then the fifth. So remember this difference between sort and order. So it may seem like they mean the same thing, but sorting actually happens on the data. Ordering basically tells you what should be the correct order based on if you are increasing or decreasing something. I hope that is clear. So now so far, whenever we have seen collection of data, we have seen similar type of data collected together. We have mostly worked with numbers, and in that context we looked at scalars, vectors, matrices. So next level of abstraction is a list. And a list allows you to store values that may or may not be of the same type. That is why if I say, let's say x1 equals this collection, or just check the type of y. Y is made up of doubles, right? And similarly, if I check the type of v1, ignoring the NA values, it gives you double. v2 is made up of character arrays. So all the entries are taken to be of the same data type. What we can do is, let's say if we start by, so there are different ways of defining lists. So one way is, let's say we define a matrix, and I'm saying, okay, give me the first 50 numbers. Let's say we work with 5 rows and 10 columns. We can fill it by row if we like, we can fill it by column if we like. So, and execute it. This is M1, and if we check the type of M1, it's made up of integers because we use this colon. Now what we can do, so we know how to access the elements. So if I just say 3, 4, so it looks at the third row and the fourth column, and that is 24. So that is what it is returning. So if I set this equal to Bob, let's say. Now notice there was a sudden change here, and if I return M1, so you can see the difference, right? Now the problem with this, what we wanted to do was have a matrix of integers, just replace one of the entries by a string, and we wanted to have this collection of numbers and string. But what has happened is the moment I change one entry, everything else has changed. So now if I check type of M1, it says character. So even the other entries, which are still numbers, have been automatically converted into characters. Because the reason for that is, so why the numbers were converted and not the string is because each of these numbers can be treated as characters. But a string, how do you convert a string to a number? So that operation is ill-defined. So that's why R does the most straightforward thing. So it converts everything to a string. So a better idea would be to just, let's say, choose a different example. Let's say I have a matrix M2. Oh, let me make this a little smaller. So this is M2, which is a matrix of numbers. And let's say I say M3 equals a situation where, okay, to define a duplicate. So the same thing, but just call it M3. And what I want to do with M3 is, let's say, let's change some elements. Let's make the 1, 2 element a character. Let's also make the 3 element a character. So now M2 and M3 are different entities. They work in different ways. What I can do is use this list command and bring M1 M2 together. Oh sorry, I wanted to work with M2 and M3 because M1 M2 is more complicated. So yeah, this is cleaner. So now you see the way this data is being represented. There are these single square brackets designating the row number and column number inside each matrix. But there are these other numbers, 1 and 2, which are inside double square brackets. So what do they mean? So when I've defined a list of matrices, I've increased the dimension by 1. Now, normally, in mathematics we work with, so when we are doing calculations, of course we work with scalars, we work with vectors and matrices. Now you may ask that, okay, an intuitive understanding of what matrices correspond to is tables. So we can have tables of data, tables recording the marks of different students in different subjects, and many other such things. So where does the third dimension come into the picture? So one way to think of it is when you are trying to store pictures as data. Now, a picture can have multiple information stored in it. So the first one is, let's say, just the length and the width of the picture. That will give you the size of the picture. But pictures also have colors. So you want to describe, I mean, there are different ways to describe the color of a picture. There's the RGB notation, red, green, blue, and there are some other ones. Or you can just give a saturation value, color temperature, and so on. So this extra information has to be stored in a different dimension. I mean, it cannot become just added to the length or width because they describe different features. Now you can go one level higher when you're dealing with videos. Now what are videos? Videos are just continuous sequences of pictures or frames. So everything that you need to define a picture, of course you'll need that to define a video. So if I have these 3 dimensions, length, width, and then this color, but you also need for videos something called time. So because you're storing it time wise. So it's not just a collection of random pictures, there is a flow there. So then you introduce the 4th dimension, and this is where data structures like lists are very useful. So you can keep generalizing generalizing to higher and higher dimensions. Now that we have a list, how do we access the elements? So this is where things are a little different. So for M2, we would have just specified the row number and the column number. That would have given us a number or the entry which is stored there. Now similarly for M3, let's say 1, 2. That's where the character C was stored. But when it comes to lists, okay, I did not store this in a variable, so let me store this in a variable. Let's call this L1. Now you can see automatically there are levels involved. That's why it's showing me this. There is a structure within this list. There is an integer matrix and a character matrix stored within it. That's why the way it is being represented is also slightly different than what you are seeing for the matrices and other data. So if I call 1, does this work? This works. And another way to do that is to be more explicit and just put both the brackets. Because you see, when I give both the brackets, it's exactly able to pinpoint what we are asking for. It gives me this. But when we just put single square brackets, it is still naming this fragment or this element as this double bracketed 1. So it's a better idea to access the elements of the list using this double bracket notation. And of course, we can check the type, what exactly is stored in the list, in the first position. So it just says this is something which is made up of integers, something made up of characters. But if we use single bracket notation, you can see based on this output alone that what this is returning is not what is stored at that position. This is just returning a sublist of sorts. That's why if you just put single brackets and say 2, it is still a list. Or you can do the same with 1. Because there is this third dimension. Number of elements is just 1 there, but the third dimension is still there. So that is a list. So you have to be careful about how many brackets you are using, square brackets, when you are trying to describe or obtain the sub-elements of a list. Now you can go one level deep. So we already know what's there in as the first object. Now I can ask for, I can give more information. So what is the first element of this guy? Or since I already know these are matrices, what is at 1, 2? Or let's say 4, 2 is out of bounds, it should be 3, 2. So this can work. Again, if you just give single brackets when accessing the list elements, not the elements within the elements, then this causes a problem. Because you see, this was returning a list, and the list does not have any 3, 2. So to do the same thing, you would have to put, because that list has only one element and then 3, 2, then this would have worked. But that is redundant. Why would you do that? You'll just put double brackets and the element you are interested in. Now, of course, you can have list of more simpler things as well. Let's say Monday. Let's say 2. And some other number, 12 maybe. So again, you see, each element, so there are sublists that you can access, and within those lists you can have different types of data. You can have simple data like these strings and numbers, or you can have more complicated data like matrices and so on. So I think lists will be covered in more detail in the coming week, but this was a brief introduction to lists. So, do you have any questions or doubts or any issues that you've faced as far as the lectures are concerned? Anybody? Because if there is no problem, then we can end today's discussion in time. So, okay then, I'll see you guys next week.